Hello. Okay. So what we are doing right now is the L293D, which we saw in class last week. So this is a motor driver board. This motor driver board is supposed to amplify the signal given by your Arduino and convert it into 12 volts or 9 volts, whatever is required for your motor. I'm audible?
Yes, sir.
Okay, cool. I'll just mute both of you. In case you have any questions, you can ask me by unmuting yourself. All right.
Yes, sir.
Okay. So what I will need now is about 4 or 5 jumper wires, one Arduino board, which I'm getting quickly. How are your holidays going on, guys?
Sir, they're good.
Good. All right.
They're good, guys.
Good. 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 Okay. Cool. So, okay, I'll just do a quick revision of this board. What this board does and what are the parts that are there on this board. When you look at this board,
Guys, good. Okay, good. So, okay, I'll just do a quick revision of this board. What this board does and what is.
then presenting the screen.
Sir, I can't see anything. The Just Robotics screen is there.
Oh, the screen. Okay. Now, can you see my screen?
No, sir.
No.
I can't see anything. The Just Robotics screen is there.
Oh, the screen. Okay. Now, can you see my screen?
I don't. No, sir. No, sir. I can't see anything. The just robotics screen is there.
Okay. Now, can you see my screen?
No, I don't. No, sir. No, sir. Can't see anything. The just robotics screen is there.
Now, can you see my screen?
Sir, yes, sir. No, yes. I don't. No, sir. No, sir. Yes. Can't see anything. The just.
Okay, cool. Okay, so quickly, just going through what we are supposed to do. Okay, this is the L293D IC, what we call as a motor driver IC. And this is where I connect one of the motors. This is where I connect the other motor. And this is where I connect the battery terminals. Now, I will just connect the battery quickly to this so that you understand what's happening. So the negative of the battery gets connected to this part here. So there's the negative of the battery. And this is the positive of the battery. So now that I've connected the battery clips, let me connect the battery. You'll see that the light glows. Okay. I'm just connecting one of the batteries. I'm leaving the battery open, or I can even connect another battery here. That's all right. Yeah. So this is done. So my board is powered on. You'll see this LED, which is the power LED. You'll see PWR written quite close to the PWR, which indicates that it's a power LED. This is where you connect the 9 volts, and this is where you connect the ground. Yeah. So this is motor L1, which means this is the left motor, and this is motor 2. Okay. So I connect one of the motors to this, and I connect one of the motors to this, and when I connect the other motor to this. Now let me just connect one of the motors to this and see what's happening. But before that, I will need a multimeter to just see what is the voltage that I'm getting right now. So here I have a multimeter. Okay. I'm just connected the multimeter to say 20. So to measure voltage, the range is less than 20 volts. So let me connect it to the battery and check what the voltage is. So positive and negative. It reads somewhere about 8.98. It's close to 9 volts. So here, what does it read? So I have to keep the black color part of the multimeter, black probe of the multimeter, to 0 always. Okay. So my reference 0 is this point. Okay. Let's see what's the voltage here. The voltage is, say, it's about 0.13 volts. Okay. And what is the voltage of the other pin? It's again 0.12. Let me check for the other side of the motor. Okay, it's 0.14, 0.12. Okay, this is 0. Interesting. Now this little voltage that you'll see here, that 0.12 or 0.13 is what we call as the leakage, because of the leakage current. It's because of the IC itself that there's little amount of voltage. Now this part of the board, if you see, is where I connect my input from the Arduino board to this board. Okay, so when I have to connect an input from the Arduino board, so you can, when if I take it very close, you would see that the first part is 5 volts, the second is 0 volts. So if I keep my multimeter and check in between this, I should be able to read about 5 volts. Okay, let me check it. So you'll see, oh, I've reversed it. So you'll see that the voltage is 5 volts, 4.97, approximately 5 volts. Cool. Now this is done. Now most of you would have a question as to what this part of the IC or the board does. This part of the board ensures that this voltage here is always 0. Okay, suppose you want this voltage to be 9 or whatever battery voltage you're connected here, which means there's basically pull up or pull down to the input. If I want the inputs to be by default 0 volts, I will connect it in pull down mode, which is by placing this connector here. And if I want it in pull up, which means by default I want each of these pins to be 5 volts, 5 volts, 5 volts, 5 volts, then what I'll do, I will connect it here. So when I connect it here, let's see what's the voltage that you will see in the multimeter at the motor terminals. Okay, yeah, so I have to keep it one to the reference ground, and then one reference ground, and then one of the pins. It should show me somewhere around close to 9 volts. It's not happening. Okay, it's in pull up mode. Okay, this seems to be not functioning. That's all right. Let's get back to pull down. I'll look at it a little later. Yeah, so once we have this board ready, now that I know that each of these pins are 0 volts, that's the reason why we are getting 0 volts here, 0 volts here, 0 volts here, and 0 volts here. The moment I make any of these pins 5 volts, so the very relative term right now is this is 5, this is I1. The same gets amplified and comes here as motor out 1. Okay, this is I2. This gets amplified and comes here as motor out 2. I3 gets amplified and comes here as motor out this point here, and I4 comes in to this point. So when you're looking at it, this is I1, this is, sorry, O1, output 1, output 2, output 3, output 4. The same thing is input 1, input 2, input 3, input 4. Get it? I1, I2, I3, I4, O1, O2, O3, O4. Cool. Now let me just connect a motor to one of these terminals. So if I just connect the motor to the battery, the motor will start rotating. So here's my motor. My motor might just require, okay, a wheel. You'll see that the motor is rotating. So I just connected it to the battery. Now, when I connect it to this pin here, the motor doesn't rotate because the voltage here is 0.12 and 0.12, and that's the reason why the motor doesn't rotate, because the potential across the terminal is 0. Will the motor rotate here? No, the motor doesn't rotate because the potential is still 0. Now, when this is happening, let's just pick up a simple wire and try to change . I'll just pick up, these are called jumper wires. Let me just pick up one of these wires. I'll just say I have a color yellow. I connect one of the pins to 5 volts. See this up front, up close. Connected one of the pins to 5 volts, and I'll connect 5 volts to I1. Okay. When I connect 5 volts to I1, you'll see that the LED on the board glows. Okay. This means that there's a difference in potential in these two pins. Now let's measure what that potential difference is. Ground. This pin has now become about 8 volts. There's a potential drop because of the IC. This has become 8 volts. This pin, which is because I connected I1 to 5 volts, now this pin has become around 8 volts. Now I2 I've not connected to anything. I2 I've not connected to anything. So this should remain 0 or 0.1. Yeah. Okay. Now because there's a potential difference, this is about 7 volts, 7.8 volts, and this is 0 volts. When I connect the motor to these two terminals, the motor will start rotating. Okay, so let's see what happens. You can see that the motor is rotating. All right. Now the LED is in a color which is the LED color would be, I would call this red or amber. Now this is in one direction. This is a dual color LED. So when you have a different potential, when you reverse the potential, the color will change to, say, yellow or something. So now let's change the potential power, which I said by default these pins are 0 volts, which means all of these pins will be 0. Now that I've connected 5 volts to this pin, this has become amplified to whatever battery that I've connected to. The battery is almost equal to about 8-point change, and I'm getting about 8 volts at this point. Now let me connect this to I2. I'm connecting it to I2, and you will see that the LED glows green. Now, there's no way I can differentiate because of the camera, but it glows almost green, and it glows almost green in color, because it means that the polarity is reversed, which means when I connect my multimeter and check, this pin is supposed to, the pin that was output 1 is still will be 0 volts, 0.12, and O2 or output 2 will now be 7.8 volts. Okay, now this, whatever was 5 volts here is now got amplified to about 7 volts. Okay, which means my motor will now start rotating in a reverse direction than what it was previously. The motor starts rotating in the reverse direction than what it was previously. Okay, so if I want to change the polarity of the direction of a motor, all I have to do is, now the motor is going clockwise, and now the motor is going anti-clockwise. Just by controlling I1 and I2, I am able to control the motor's direction. Right? Yeah. So the same thing applies to I3 and I4, which will control this pin, these two pins here. Now let me connect the motor to these two pins and check what's happening. So just a quick recap. When I connect this pin to I1, the motor starts rotating in one direction. Pulls to I2, the motor starts rotating in the other direction. Okay. Now when I give it to I3, you'll see that this light is glowing now. I'm individually connecting 5 volts. Now I do not have too many 5 volts on this board to do the connections and show all 4 motors at once, but my Arduino board has connectors as pins, which is 14 digital outputs or inputs, which can give 5 volts, like how we gave it to LED last class, and that can be connected to I1, I2, I3, and I4 to control this motor. Okay, now let's quickly do for I3 and I4. Now I will connect it to I3. Now you see that it's glowing green because I told you already that I3 is this pin. Okay, now this will glow green, and when I connect it to I4, it will glow red. Okay, this is red in color. You'll see here. Red, yeah, red. Now because I3 and I4, you will be able to change the color. Change the direction or the polarity. Now let's see how it functions when we connect it to a motor. Give me a moment. Okay, let me check the voltage. If I'm getting some voltage here, not getting any voltage difference. Okay, fine. So which means I have to connect the motor not just to the terminal on top, but actually mount it and to the terminals here, which I'm doing right now. So I'm connecting motor terminals to this. Okay, but why isn't that? The motor is not rotating. Okay, the board looks faulty. Let me just change the board for you. Okay, first thing that you do when you disconnect the board is to remove your battery and ensure that the board is powered off. And then dismantle the connectors. So let me quickly connect it. Yeah, so what we are looking at is the L293D board. We're just doing a recap connection of this. When you turn anti-clockwise, the screw terminal gets loosened. When you turn clockwise, it gets tightened. So it's righty tighty, lefty loosey. Turn right, it gets tightened. Turn left, it gets loosened. Right. Okay, so quickly I'll just connect my power supply, which is 9 volts. Supposed to be connected to the board. We're through with it. And then let me just connect the battery. Okay, and let me just connect one end of this to the 5 volts, and then we have connected to this. Let me check with the motor if it's functioning. Oh yeah, it's functioning. So will I be able to just change the direction by changing this pin? Maybe yes. So you see that the motor is going anti-clockwise because I connected to I4. Connected to I3, it starts going clockwise. Right? Cool. So this approach will help us to understand how it's connected. Now what I'll do is I'll connect, say, my right motor. If this is the right motor of my robot, I'll connect it to motor output 3 and output 4 on the right hand side. And my left motor, I'll be connecting it to these 2 pins. Now the direction doesn't matter because you can anyways change it a little later, because if it's turning in the reverse direction, you could reverse this polarity or reverse these pins, I1 and I2, you can interchange, or you can reverse it in the Arduino program. Whatever you used to make high, you make it low, and whatever you used to make it low, make it high. Now for connecting between the Arduino board and this particular cable, you will require these pins. This so let me just get the jump wires. I just misplaced the wire. Oh yeah, I got it. But yeah. So what you're using will be a jumper like this, which is called the female, and the male part of the jumper. Now you will need one of these things here. So for example, if I'm picking up one of these pins, one end of the pin will go to I1, and the other end of the spin will go into your Arduino board, where you have connected pin number, say 2 or 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever pin it is. So you connect one end of the board to this, and one end of the wire to this, and one end of the wire to this. Now how would you do it? I'll just show it with 4 pairs of wires. Just pick up 4 pairs of wires like this, and then connect them in a fashion. Just pick them up. I put for I1, I2, I3, and I1, I2, I3, and I4. Okay, so this is tight enough, and just ensure that the orientation of all of this remains the same. Whether you do it the other way or this way, it remains the same, and preferably we put it outside. Why is this required? Why will this pin be required? Is for you to measure, if you want to measure any voltage. Now that the conductor part of the connector is not available, you would use this pin, and between these pins you can measure the voltage that you actually get here. Now once this is done, the other end, where does the other end go? The other end will be connected to your Arduino board. Now, how will you connect it to Arduino board? In the program, you will choose different pins, like how last class we chose pin number 13, 14, 10, 11, 12, and 13 for 4 LEDs. We chose 4 pins right now, and then this one I will connect. I will choose 4 pins. I will choose say pin number 1, 2, 3, 4. Can I do that? Yeah, I can do 1, 2, 3, 4. Okay, so I1, I2, I3, I4, I will connect it to pin number 1, 2, 3, 4 on my Arduino board. You can see this 1, 2, 3, 4, which is connected to Arduino board. Now this is ready. Okay, now in my program, what I will do is connect this, write a program to make this motor go forward, reverse, backwards, rightways, which we'll be doing in the coming session. Okay, now this is done. I will show you the program, but I will not be uploading the program because I would want you to do it, because this has to be set up on your robot. Now this connection is made. Now who will power up the board, the Arduino board? Somebody has to power up the Arduino board. Now as long as I connect the USB connection to this, the Arduino board is powered up. The moment I remove the USB connection, if the function, this has to function, then somebody has to power up this board. Now what we'll do for that is, we will, since we already have 5 volts and ground on this board, we will connect 5 volts and ground from here to the Arduino's power in, which is you see 5 volts here, and ground, which we call as this is what is the 5 volts and this is the ground. So we connect 2 pins from this board to this, and you'll see that the Arduino board will get powered up. Now this class is only for the wiring. So once your wiring is done, so I've just picked up 2 wires. The black I'll use for negative and the white I'll use it for the positive. Use contrasting wires, so something like black and white, red and black, orange and black, so that you have a contrast between identifying which is positive and which is negative. Now what I'll do is I will connect this here. So I will connect this. Oh, sorry. Go reverse. Yeah. So white is 5 volts and black is ground. Now I'll connect this to the board, Arduino board. You'll see I'll first connect the ground to this pin. This is the ground pin. Okay. And then I'll connect the 5 volts pin. You'll see that the Arduino will power up. The Arduino powers on, right? Now the board is ready to use. All that you have to do is, when you're programming this board, be aware that, ensure that you have removed the battery, then program the board, remove the USB connection, and then connect the battery. Go again. When you want to program the board, disconnect this or disconnect the battery. Okay, the Arduino should not be powered on by this board when you're programming the Arduino board. So when you're connecting the USB cable to the Arduino board, do not power on using this board. So what you do is you will quickly remove this, which means now the Arduino is not powered on. Okay, so the power supply from this board is removed. Now the Arduino you will plug in the USB cable, program your Arduino, and once that is done, you'll connect this back again here. Yeah. Okay, now the Arduino will power up, and whatever program you've written for your Arduino, that is what will function with your motor. Say if you've written high pin digital pin 1 is high and digital pin 2 is low, then you'll see that the motor that's connected to this will start rotating in one direction. If you make pin number 2 and 3 and 4 low and high, then you'll see the motor connected here will start rotating in another direction. So you can give a delay and then again quickly change the program to accommodate different kind of different motor actions. Now, how would you do the program? Quickly, I will just show you how a program is written for this. But we will not be uploading the program right now. So I'll just quickly shift to the Arduino screen, my board. Yeah, so this is my screen. I hope all of you remember the codes that you've written last class. So let me check if we have any of these codes that you've written last class. Open codes. No. Okay. Libraries, documents, Arduino. No, I don't have. Oh yeah, I might have it here. Get it. Projects. No, I don't have. Um, okay, let me quickly check for the code. I just put it. Okay, I don't seem to have a backup of the code, but well, I will write the code this way. Okay, so quickly I'll write the code. So not wasting much time. How do we write the code? Do you not write the code? No. Yeah, so let's quickly write the code. We'll keep this here, void setup and void loop. So what will be the first part of the program? I'll have to say int left motor 1 equal to, so let me call left motor, yeah, left motor 1 equal to, which pin I'm connecting it to? I'm connecting to pin number 1. Cool. I'll say int left motor 2 equal to 2. Okay, when I say left motor 1 and 2, it is actually referring to two terminals of the motor. And I say int right motor, motor 1 equal to 3, and then int right motor 2 equal to 4. So 4. Yes.
I'm sorry. I'm sorry. I can't see any. You're not writing anything. It looks like.
What is it? Hey, hold on. Why is
Yeah.
it? Oh, give me a
On
moment.
my screen, it looks.
Oh yeah. Okay, fine. Just give me a moment. I will just do that. It is showing a different screen. Thank you.
Welcome.
Now you should be able to see.
Yes.
Okay. I was just writing 8. Yeah. So because I connected 1, 2, 3, 4, which is nothing but I1, I2, I3, I4, and I will eventually connect it to left motor 1, left motor 2, left motor 3, because whatever comes on the output is where I connect the left motor. So I'm referring this to as left motor 1. Or I could also write, instead of this one, I can say I1, and I can say I2,
I2.
and I say I3, I4. I can do that as well. But right now, just to make things simple, I will things easier. I will do it this way. Okay. Now, once I've declared my variables, I have to set up. Do I set up? So I have to put my setup code here in between the braces. So the first thing is I have to define the pin mode. So each of these pin mode which left motor 1 equal to, oh sorry, I forgot. Oh, equal to output. Is that how I write?
Yes.
No, that's not how I write. This is how it's supposed to be.
You should put the brackets.
Output. Right. Yeah, so let me copy this. Control C, Control V. Okay. Right motor 2,
Two.
right motor,
Right motor.
left motor 2. Okay. So I've declared all of my pins as outputs because I'm supposed to control the motor, which is outside the board. I'm not supposed to take any inputs to the board. So I'm putting my main code here. How do I put my main code here? Again, very simple. I have to say digital right. Which pin? Okay. Left motor 1, comma high. Okay, which means
High.
I'm making I1 high. Okay, and digital
High, low, high, low.
right, yeah. Left motor 2
Low.
as low. Yeah, which means this is fair enough to run one of my motors. Digital right motor 1, comma high. Oh, let's see this. I'm not supposed to do high here because then the motor will start rotating the other direction because right motor 1 will point to pin number 3.
Yeah.
I can do it that way. I can also write high and then change it a little later in my wiring connections. That will also be fine. So, but then let me make it low and then
High. Digital right
left,
motor.
sorry, right motor 2, high. This will make my motor go in, both the motors go in one particular direction. That is it. So I'm done with, say, making my robot go either front or right or left or back or whatever it is. Now, once this is done, suppose I want to change. Let's see how this functions. So I'm also going to, because we have just another 5 minutes, I will quickly connect a motor to one of the terminals and show you what's happening. But I will just show one motor. I will not show the other motor. So this is supposed to be terminal 1. So where's my screen? Okay, okay, let me quickly go upload the code. Let me quickly upload the code. You will have to see that I am sharing the window.
Okay.
I will see it.
Console.
Okay. Yeah, no. So what I'll be doing right now is to disconnect this power supply from here, keep it aside. Oh, just ensure that these two don't touch each other because it's 9 volts and this, sorry, 5 volts and ground, they might become, I mean, into a short circuit. Now I'll connect the cable and you'll see that the Arduino will just power on. Hear a nice sound. And then let me just upload the code. Okay, now that we've seen the code, I'm quickly not show. I mean, I'm showing the how the code is uploaded. Uploading the code is asking me to save the program. I say motor control. Okay. This board seems to not be working. It looks like somebody is just messed with the system. It's not detecting. So you can see that the Arduino board is powered on, and I'll also connect the to this side. Okay, I have to connect the motors to this particular end. Okay, now that I've connected the motor. Yeah, so I hope you've understood the code. So we're just trying
Yes,
to
sir.
make the motor go left and right. I'm just doing it for one of the motors, not the other motor. Oh, this system seems to have a little problem with detecting the Arduino board itself. Okay, now it's done.
Okay.
Tools for COM6 and upload the program. And now you'll see that the light there blinks really well when it's uploading the program. So you know that the uploading is happening, and now the motor is rotating. And the motor is rotating clockwise. Okay, what is it that you can see that motor is rotating clockwise? Yeah, good. The motor is rotating clockwise. Now that the motor is rotating clockwise,
Okay, yeah.
it's going this way. I'll just give something to this so that you can see. Okay, now quickly what I'll do is I will also share the screen in such a way that you can see the entire thing. Yeah. So in the program, what I'll do, I'll just make left motor high and high and upload the program. Uploaded the program. Now what happened is you'll see that the light here is not green anymore or not red anymore. The light here is what color?
Look white.
No,
Right,
it'll be a mixture of both the colors because both these pens
like
are high.
something.
It'll be
Something
green
like
plus
oil.
red. Green plus red. Yeah, it'll be somewhere close to an amber or orangish color.
Yeah.
Okay, that's what the light is because this voltage, both of these pins are at the same voltage. Now, how do we see that? I have a multimeter. What happened? Okay. So, the motor is rotating because of the loose connection. Now, let's quickly see the voltage at this pin. The voltage is about 7.15. My battery is draining out, and here also the voltage is about 7.15. So in both of these pins are the same voltage. Now when I do this, I'll see that it is at a zero potential because there is no potential difference. That's why the motor is not rotating. Okay. Now the motor is rotating because the voltage, there is some 5 volts potential. Okay, that is because of a loose connection here. A little loose connection. Yeah. Now you see that the potential is 0. That's why the motor doesn't rotate. Right. Now when it's rotating, it's about 5 volts. Yeah, around 5.3. Some loose connection. Yeah. Okay. Now it's fixed. Okay, so this is with respect to the motor. You can connect the other motor on this side, which means other motor on this side. You'll see that the motor will rotate. Now that I've stopped the motor, it's not rotating. Let me just do a simple, quickly another experiment where I will change. I'll just change this right motor because I'm not using the right motor anymore. Okay, so I'll just give a delay of say 1000, and then I will make say same thing. Control C, Control V, okay, then Control V, then Control V. So I want different things to happen. I'll just give low, high, low. So motor will go in that one direction, then I'll make low, high, the motor will go another direction, then I'll make low and yeah, low and low.
Low and low.
It's low and high. Okay, cool. So let's upload this code and see what's happening. Now remember that I'm not connected to power supply at all. I'm just using the power supply that was there in the 1 second it goes clockwise, another second it goes anti-clockwise, and then it stops for a second. Clockwise, anti-clockwise, clockwise, stops for a second. Anti-clockwise, clockwise, stops for a second. And this is what we are doing with motor, and this is what is required for motor control. And the other motor for the right hand side, you will have to do it by yourself. That's the assignment. That's the challenge for the holidays. So by the time you come back from the holidays, so when I remove the USB connection, you'll see that all of these stops because the Arduino board is no more powered on. Arduino board is no more powered on. Now if I have to power it on, what I'll have to do, I'll just connect
5 volts and the ground wire.
Yes, now it's powered on. Now I'm just not connecting anything. I'm just removing everything else from the board, which means it's just like how it's on my Arduino, on my robot, just with the motor and just this, nothing else. So it's just one robot. Which if I do it for a robot, what will happen is my robot will keep rotating. Will go forward, go reverse for a second, and then again stop. So forward, reverse, forward, stop. Forward, reverse, forward, stop. So this is what is happening. So this is for one motor. Do it for the other motor as well. So you'll be able to do it. So if you have to see how you do it for the other motor, this is what do we do. This we did for one motor. What I can do is I can just copy this version here. I mean this part of the code here. Back again. Control C and put it here. This is what I have to do for the other motor. Now this is for my entire robot. This code is for my entire robot. We do this in class as well next time, so you don't miss out. For those of you who missed out the session, see the video, watch the video, and you'll be able to. Hope you'll be able to follow it. If not, no problem. We'll catch up again on the first week of October when we have a class, and then we'll do this robot really well. So we need to have a robot running. So right now what's happening is I've uploaded this code that you can see that the motor is rotating. Now you can have a different set of codes. Suppose you want the robot to go, say, forward. Okay, we do this. Low, high, motor goes forward. High, low, high, robot goes right turn. Low, high, again robot goes forward. Low, high, robot goes left. Suppose you want a robot to go reverse, then you do high, low, then high, low. Right? So this is it. The different delays, you want the robot to go straight for about 10 seconds, just make it 10,000. The robot will then take a right for, say, about 1 second to turn right, and then, or you want to turn right for 2 seconds, do this, and then the robot goes straight for again 1 second. Yes, and then again it goes reverse for 1 second. So this way you will be able to make a robot go in different directions, different designs, all by programming, and let the robot on the ground and go running. Thank you for being part of this class, and have a great weekend. Happy Dasara, happy holidays.
Thanks, sir. Bye.
Bye.